Hi, everyone. My name is Olga. I'm really happy to be here and really happy that you decided to join this talk. I'm a data scientist at AI team at Wix. And during last few months, part of our team inside of training our own language model is trying to figure out how we can take models from other companies and actually calibrate them and use them inside Wix. So we are constantly exploring what are the best ways to build reliable solutions based on LLMs. I see people are coming. So I will start a bit again. We are actually constantly exploring how to build reliable solutions based on LLMs, and we are also following how other big companies are doing it. And today in this talk, I will want to share with you some insights. The flavor of this talk will be a bit unusual because I will be sharing with you a bunch of topics which you need to be familiar to build these reliable LLM applications. And also I will give some insights what are initial choices of tools for this. And then I hope at the end of the presentation I will just try to tie it all together and to see a bigger picture of how to build reliable LLMs, reliable apps using LLMs. And I want really to begin the conversation with discussing how sorry for that, just yes? Okay. So I will want to begin the conversation with discussing a bit how actually this technology works in the nutshell, how brain of LLM works. But don't be scared, it's like it will be very light. I will just give a small intro. So LLMs are driving AI in companies under different names. It can be AI assistant, generative AI, artificial intelligence, and now you know agents are everywhere. But in the nutshell, it is still a language model, and what it does is the following. It takes a sequence of words, let's say the best ice cream flavor is, and among all words it knows, it tries to predict what is the most probable next one. According to GPT-4, currently it's in database the most popular next word is chocolate ice cream. It's nice to know. And what it does following, it takes this word and appends it to the sequence and generates a new one. And so you have like nice word generator. It can generate new and new word, and then you can add a little bit of randomness, and suddenly, out of a sudden, this tool can generate essays, write emails, and do a lot of different stuff. And the thing is that once you scale these models and you are training them on more and more data, it knows how to predict these probabilities very, very well. And once it generates the text, you can even not distinguish if it's generated by LLM or you are reading something in the internet. So that's what actually scale does. And then I'm so optimistic and go and ask LLM to write me a code for something because we're engineering conference. All the examples will be about code. I'm asking it to write me a code on how to hide and show image. But what I see is that it actually starts to complete my prompt. It's not answering the question. Why? Because this technology, initially, it was developed only to predict the new word, and it does it very well. And there was a revolution in this field in 2022 when OpenAI team decided, why don't we take this base LLM, which knows a lot of facts and can generate texts, and why don't we give it a bunch of examples of question and answers? And OpenAI collected around 50K examples of instructions, like translate into Python code something, and they showed instruction and what is the correct answer. Rate this review or write this summary. And this is the way actually how you are getting instruction-tuned LLM, and that's how ChatGPT was born. And actually gathered 2 million users within first month. So from predicting just next word, we are going to a model which has all the base model knowledge, but it can follow instructions and complete prompts in the question in the form of question and answer. So now if I take, like, these models, they have the same base model, but the new one, instruction tuned, has this a small model on top. Now it can still generate next words, but in the form of question and answer, and solve my tasks. So when you are building LLM-based applications, the initial choice you should make is actually what LLM to use. And LLM's market is growing so fast, and I just want to highlight what kind of things you should consider when choosing LLM. First of all, most probably in reliable production applications, you need to use instruction-tuned LLMs. I just don't recommend to use any other. Another thing is params. Here, most probably the bigger the better. Another one is how big instructions you can paste to this LLM, how much context you can add, and how long output it can generate. It's another feature. Some of you may need fine-tuning, but most of you will not. Trust me and relax, you will not need fine-tuning. Also, there are different licenses, proprietary or open source. For open source, it's much easier to fine-tune and also to scale to make the model faster. And I think that the most critical components and criteria for the model are actually speed and quality, and that's where you will always need to balance, because, for example, the best model, one of the best models right now is GPT-4, and it's very slow. So first thing you need to do is actually to choose your LLM fighter. As you can see, there are lots of different models. Wix has developed a model hub where you can try a few models, write prompts, and tune parameters, and see which one works best for you. Currently, we support only OpenAI models, but sooner it will be more. So basically, we are taking this base LLM, and now the question is how we are transforming it to something which is useful for our business, useful as a tool. I will show an example of Velo AI code assistant. So we want to take LLM and let it help our users with coding questions about Velo platform. I hope everyone is aware what is Velo is. Oh, yeah, okay. Okay, so it's like very simple. We want users to ask questions about some coding scenes and get back the response. But like, actually, what do we need to build this system? And there was a very nice article by Anderson and Horowitz investment firm where they show that actually LLM itself is a very small component of the bigger architecture. And now we will move on, and I will just, really, you don't need to look and read what is there. I will tell you three main concepts, and that's what I really want you to take away, only these three main concepts. You can forget everything else, but once you know this concept, you will always know how to build your LLM product to production. The first concept, so as I said, instruction tuning revolutionized LLMs industry, because now you can ask models to follow your instructions. But there is one small note, that these models were trained to follow human instructions, but not all of them. They were tuned to extract some information from text, to generate essays, to brainstorm on ideas, to rewrite, to summarize, to close K. So it means that they had very specific set of tasks which they can do very well. What it means that most probably our application is a bit more complex. And it means that, let's say that we are building Velo Code Assistant, and we will be getting questions which are a bit different, like how do I hide and show an image, or why this code is not working, or what is better Wix or Shopify. And base LLMs, they are not ready for that. And that's why what you need to do, like, and always remember, you need to break down the problem into smaller ones. First, we'll think, is this question related to Velo or not? What is this question topic? Then we will generate some answer related to topic. For example, some users want to troubleshoot the code, and it will be one flow. Other users want to generate code, it's other flow. And maybe at the end, we will want to add a bit of Wix flavor and add some Wix tone of voice. So in terms of LLM, the solution is following. You need to combine language models into chain. So you will be calling a language model one by one. So first moderation, LLM will decide if it's question related to Velo or not. The second one will classify if it's question to generate code or if it's question to troubleshoot code. The third one, depending on the previous model response, will know what to do, whether to troubleshoot or generate. And the fourth one will always take everything and make it beautiful in the Wix tone of voice. In terms of orchestration, you will need tools to do this. And like usually, you will go and write your Python glue code to combine these models all together. But also, there are frameworks like LangChain, Llama Index, and other smaller ones which allow you to really quickly prototype. And they have also templates for different use cases, templates for chains for different use cases. And language models are still language models. They generate in text. They are really great in simulating common fictional personas or do some very simple tasks. But for them, it's really hard to plan. They cannot execute Python. They cannot search verb. And that's why there is an approach. You can augment language models with tools. So basically, you can give these models access to real-world tools like search or archive or Python. And you can do it in two different ways. First one is via chain. You will have one specific LLM which will generate input for a tool. For example, if it's search, it will generate input for search in Google. This tool will return results and pass it to the next LLM. This solution is the most reliable because you can control all the steps of it. And there is another solution via plugins. When you give model tools, you say that you have 3 options to choose. You can go to SQL database, or you can go to Google or something else. And please decide on the fly which tool you want to choose. And this solution is much more fun. You never know where it can get you. But you know, like it's also a thing to try. So what you need to remember here, that models really like to work as a team, always. So that's why we need to decompose our task into smaller ones, or ask LLM to do so, and use some orchestration framework and tools to make the task done. So it was the first chunk. The other chunk related to model knowledge. You know, GPT knows a lot of things. It has more than 100 billion of parameters, 80 layers of reasoning, and it encodes a big portion of internet inside. But the thing is that this portion cutoff is September 2021. In the majority of real-life applications, it's not enough. We need fresh data. For example, in customer care, our database of articles is updated every 5 minutes. Is there a way you can add knowledge to the model without actually retraining it? And in 2020, Meta team, so you can see that researchers are working in a team. Like OpenAI created Instruct model, and Meta created this approach, which is called RAG. Who have heard about RAG? Yeah, I know that you. Okay, so they say that you actually can add knowledge to the model without retraining, without even knowing how it will happen. What you need to do, along with passing the question about Velo, for example, to GPT model, you need to add to this question also some information from your database which is relevant to this question. So let's say how to change color of a button. I will go to Velo documentation and find relevant articles which will help LLM to solve this thing. And the prompt will look like following. Please answer the question using the context below. No magic. You don't need to be super technical about it. So this retrieval augmented generation is super cool thing. It allows to add knowledge to model without fine-tuning. It allows to bring model to a separate space, which is super relevant for your project. Allows model to be more focused. And also it helps model to hallucinate less. So this is the architecture of so in order to implement retrieval augmented generation, you actually need the retrieval part. And I guess that for you it's something familiar. This is the thing which does not it's not really specific for LLMs. It's how do you get the best search you can. So you take all the data sources you have, you need data pipelines to load and transform your documents. Also, you need to have embedding model. I think this topic can be harder, but it's just a keyword. Embedding model allows you to transform text, images, audio to the space where actually you can find somehow a similarity between them. And you can store embeddings along with the data in the vector database. Just some highlights about the choices for data pipelines. Of course, there are many options, but what is recommended by Wix for data pipelines, we are using Airflow. Hugging Face right now is one of the best embeddings model you can use, and the most reliable database right now is Vespa. What is interesting, what is the highlight? That you have, actually you need to do this retrieval of documents very fast, most probably on the fly, and very accurate. So regarding latency and stability, it goes to vector database, but the accuracy lies in document quality, document chunking, and embedding models. So currently we discussed 2 points, which is combining language models to solve your task, and also adding knowledge. And this is the 2 key things which are responsible for the quality of the solution. But as all things we move to production, we need to test it. And the hard thing about LLMs that you need to evaluate it, and is really hard. When you check OpenAI, they say that before going to production, you need to evaluate your models really well, because things can go unexpected. Why? Because the only way to control the model is prompt, and it's something which is not super structured. These models still tend to hallucinate, and sometimes these models can get unlucky. Do you remember they are generating words, and they have some randomness. And it can come that the word they start is not something good, but they still need to continue their task, and that's just it, they get unlucky. That's why in some cases you're actually running several models in parallel and using voting. So how challenging it is? Let's take a look at Velo AI assistants. We will want to check if the code generated by model is okay. So we have a question about if Velo can dynamically generate QR code. And here our model says, yes, of course, you need to use QR code generator library from Velo. So potential problems, you can see that it hallucinates. We don't have this model at all. Also, the solution can have incomplete information, or it contains only parts. So actually, there are many, many things which can go wrong. And most probably, the only way for you to notice it is actually to go and look through all the examples. It's really hard because you don't have ground truth answer, and the output is unstructured. I can say that evaluating LLMs is really a big topic. But what really helps is when you have a few prompts and few approaches, and you are testing them, and it's really a good idea to record somewhere the best prompts you have. Before that, I was doing it in Excel sheet, in notes, wherever, in Slack channel to my colleagues. We have developed a Wix prompt hub, which allows us to store successful prompts and their parameters, and also results of these prompts. Also, it's nice to have some guardrails in production, is actually to add some small validations which you can do using rules. Is code snippet executable? Are there any PII in model output? And you can do it like this. So once you have output, you can check for some basic checks, and also you can give a feedback to LLM to fix the problem. Guardrails and LangChain frameworks allow to do this. So I still have only 20 seconds. There are 2 more tricks. I will skip them, but maybe you will have a time to have a look. And now I just really want to summarize. In order to build reliable service based on LLM in production, you need to do a few things. First, you need to choose your fighter. Another thing you need to always remember, LLMs right now work better as a team. You need to orchestrate. You can teach LLMs and add it to it your data using RAG. Don't forget to evaluate. It's hard, I know, be creative there. And the last item is just don't forget to monitor your cost and latency. Thanks.